Hello, I'm Jackie from Team 21980 Bred Pandas. In this video, I will be teaching you how to program a basic TeleOp from scratch using Android Studio. This video assumes that you already have Android Studio and the FTC SDK installed. We'll be programming a robot with a mechanism drivetrain, a lift, an arm, and a claw. There are two base types of op modes you can program in, which are linear op mode and iterative op mode. If you've programmed in Box before, linear might be more familiar to you, so we'll be using that. In Android Studio, go to Team Code, Java, and org.firstinspires.ftc.teamcode. Right-click and select New Java class. You can name the file whatever you want. I'll be naming this Simple TeleOp Tutorial. First, we're going to write extends linear op mode here. This tells the robot that this program is linear. Now, inside the brackets, we're going to write override. And below that, write public void run op mode. This is similar to the purple block you see in box programming. Above that, we need to declare the actuators we'll be using as variables. Private means that the variable can only be accessed within this program, so you need to do this for every new op mode you write. DC motor, servo, and CR servo tells the program what type of actuator we're using for the variable. Front left refers to how the actuator will be called in the program. It does not need to match what is configured in your driver station. Now, inside run op mode, we're going to write wait for start and while op mode is active. This matches the wait for start and while op mode is active blocks in box programming. Between run op mode and wait for start is where the initialization blocks go. Here we're going to initialize our motors, or assign the motors to the variable we declared. Here, we also need to reverse the motors on one side so that positive power makes the wheels move forward. For go build a motors, you'll need to reverse the motors on the left side. For our robot, we also need to reverse the right arm servo and the two lift motors, although this may differ for your robot. Let's start on programming the drivetrain first. We can declare and initialize variables to store the values from the joysticks in. We'll put gamepad 1, which corresponds to the gamepad that registers when you press start A. Each time the program loops, these values will be updated based on the positions of the joysticks. However, because of the controller, pushing the joystick up on the y-axis returns a negative value. We want up or forward to be positive, so we need to put a negative sign in front. Now we need to figure out the equations for programming a mechanism drivetrain. First, let's imagine a simple tank drive with only two wheels. For the robot to go forward, you need to make all the wheels spin forward, and to go backwards, it's the opposite. If we put this code in, pushing the joystick forward will make the wheels spin forward, and pushing it backwards will make it go backwards. Now, if we want to make the robot turn to the right, the left wheel has to go forward and the right wheel has to go backward. So we need to add power to the left and subtract from the right. Since the joystick returns a positive value when pushed to the right, moving it right will add power to the left and subtract it from the right, spinning the robot clockwise. For strafing, we can use a similar concept. According to this chart from GoBuilda, to strafe right, the back right and front left motors need to go forward, while the back left and front right motors need to go backward. So when we push the joystick right, we need to add power to the back right and front left, and subtract power from the back left and front right. Now we have the powers to be sent to the motors. However, there's something else we can do first. Since the SDK clips any values higher than 1.0, the ratio of motor powers won't be the same if some exceed 1 and get clipped down. To counteract this, we can write a function that clips the motor values but keeps the same ratio. Go under run op mode and write private void set drive powers. Like before, private means it can only be accessed in this program. Void means the function doesn't return any values we can input somewhere. Inside the parentheses, write this. We'll be inputting the values from before into this function. Now, inside the brackets, write double max speed, which is the max speed the robot can reach. Then we'll write this. What this code does is takes the higher value of the two values and sets the max speed to that. Then it divides all the values by that speed to ensure that nothing exceeds 1 and still maintains the same ratio. Finally, we'll send a new calculated power to the motors. Now we just need to implement this code into the while loop. Now we're done, so we can move on to the claw. You'll have to experiment with your robot, but for our robot, the values for opening and closing the claw were 0.82 and 1, so we'll use those. Here, we'll write final to tell the program that this value will never change. Let's say that you want to use the triggers and two buttons to open and close the claw. Left trigger or X button opens, while right trigger or B button closes. And here we'll first write a comment marking the code. Then we'll write an if statement. If gamepad 2, start B gamepad, has its left trigger pressed past 0.1, or its B button is pressed, then we'll set the claw's position to open. Else, if the right trigger is pressed, past 0.1, or the X button is pressed, then set the claw's position to close. We want to wait until the trigger is past 0.1 so the claw doesn't open or close if you accidentally brush the trigger a little. Now let's move on to the arm. We can go up here and add a variable for the arm joystick. We can use the left joystick of gamepad 2. If the left joystick is pressed past 0.2, then we can set the power for the arms to 1. We use 0.2 as a buffer to ensure that the arm doesn't move if the joystick was accidentally pressed. Else, if the arm joystick is being pressed backwards past negative 0.2, then we set the arm powers to negative 1. Else, if the joystick isn't being pressed, set the powers to 0 so that the arms don't move. Now onto the sides. We'll use the right joystick of Gamepad 2. If the joystick is pressed forward, then make the side motors set to power 1, or make them go up. If you want to slow them down, you can change the number to 0.9 or whatever feels right from testing. We'll do the same thing from before for going down. You can use whatever power between -1 and 0 and 1 for going down or up. Else, reset their power to 0. That's mostly it, but we can also implement telemetry, which sends data to the driver station for you to view. Let's try setting the amount of power the motors are outputting. We'll put it inside set drive powers, so it can output the clipped powers. Above, we can also add the claw, the arm power, and the sides power. Don't forget to add telemetry.update since that updates the data each loop. Now we're done. You can test this code and see for yourself if it works. Thank you for watching this video.